Hello and Assalamualaikum. We group from section 6 now will explain about application of DC motor for this PENT 3743 assignment.
Among the real-life applications of DC motor are electric vehicle, lift, ceiling fan and stand fan, robotic arm, electric power steering system, and also printing machine. A DC motor is an electromechanical device that converts electrical energy into mechanical energy. It consists of several basic components that work together to generate rotational motion. Among the main components of a DC motor are: first is the armature. The armature is the rotating part of the motor and is typically made up of a of coil or wire wound around a central core. It is responsible for producing the magnetic field that interacts with the magnetic field of the stator to generate torque. Second component is the stator. The stator is the stationary part of the motor and typically consists of permanent magnets or electromagnets arranged in a specific configuration. The stator's magnetic field interacts with the armature's magnetic field, causing the armature to rotate. The third component is the commutator. The commutator is a cylindrical structure attached to the armature shaft. It consists of a series of segments or bars that are insulated from each other. The commutator helps to reverse the direction of the current in the armature coil as it rotates, ensuring that the motor's torque remains in the same direction. Fourth component is the brush. Brushes are carbon or graphite contacts that press against the commutator segments. They provide electrical connections to the armature windings and allow the current to flow into the coil. The brushes also help in transferring the electrical power to the armature efficiently. The fifth component is the field winding. In some types of DC motors, the stator includes field windings. These are coils or wire that create the magnetic field within the motor. The field windings can be either electromagnets or permanent magnets. The sixth component is shaft. The shaft is the output component of the motor and is connected to the armature. It transmits the rotational motion produced by the motor to the external load or device.
Hello, and I'm gonna present about electromagnetic application in electric motor design. So the indu- so we choose induction motor. So the induction motor is a type of electric motor that operates based on principle of electromagnetic induction. It's utilize alternating current supplied to the stator windings to generate a rotating magnetic field, which induce current in the rotor, resulting in rotation. So one of the advantage is the self-starting capability. So as soon as an AC power supply is connected, the rotating magnetic field produced by the stator windings induce currents in the rotor and is enabling the motor to start rotating without the requirement of additional starting mechanism. Next about electromagnetic field generation in the stator windings. So the first point is current flow. When electric current passes through the stator windings, a magnetic field is generated around the coils. The characteristics of this magnetic field, including its magnitude and direction, are determined by the magnitude and direction of the current flowing through the windings. For the wire coil arrangement, so to optimize motor efficiency and performance, the stator windings are arranged in specific patterns, such as concentric coils or distributed windings. The arrangement of the windings directly influences the strength and distribution of the resulting magnetic field. The last one is electromagnetism principle. So the generation of magnetic field in the stator windings adheres to the principle of electromagnetism, which states that a conductor carrying electric current produces a magnetic field. By acting as electromagnets, the stator windings create a magnetic field that interacts with the rotor, initiating the motion within the motor. So this part is about interaction between the stator and rotor magnetic fields. So about the magnetic field interaction, the interplay between the magnetic fields of the stator and rotor is a crucial element in the operation of an electric motor. The magnetic field generated by the stator windings interacts with the rotor's magnetic field, creating a force that sets in motion the rotational movement of the motor. So the torque generation, the interaction between the stator and rotor magnetic fields leads to the generation of torque, which is the rotational force that propels the motor. The magnitude and alignment of the magnetic fields directly impact the amount of torque produced, thereby influencing the motor's overall performance. So, and the last part, which is the magnetic field reversal for continuous rotation. So this is a diagram of illustration. And then the first one is the principle of magnetic field reversal. So continuous rotation in an electric motor is achieved by periodically reversing the direction of the magnetic field generated by the stator windings. This reversal is essential to maintain the interaction between the stator and rotor magnetic fields, sustaining the rotational motion of the motor. And then the charging direction of the current. The reversal of the magnetic field is accomplished by the changing the direction of the electric current flowing through the stator windings. This is typically achieved using a commutator or electronic switching circuitry, which alters the current flow direction of specific interval. Then, timing and synchronization. Precise timing and synchronization are crucial for magnetic field reversal in the motor. The reversal must be coordinated with the position of the rotor to ensure continuous rotation. By reversing the magnetic field at the appropriate moment when the rotor completes a half turn, the motor can sustain its rotational motion without interruption.
Assalamualaikum, I am Muhammad Hakan. Now we will talk about conclusion. In conclusion, electromagnetic have many significance in various fields, especially in engineering fields. Besides that, electromagnetic theory is the basis for numerous technologies that have transformed our modern life, that facilitates our daily affairs. Lastly, electric motor widely used across various industries and everyday devices, such as electric vehicles, home appliances. Now we will try to assemble this motor to see its functionality of this pen. So from here we can see this is a winding and magnetic coil that will produce a magnetic field force from the electrical energy.